Today I'm going to be talking about the poorman package. This is a package I've been developing over the last 6 months or so, maybe not even that long. So let's get right to it. So in today's talk, speak a little bit about myself, talk about, of course, what the package is, what it includes. Then we'll maybe look at a brief demonstration, possibly a live demo if I have enough time. And then I'll discuss a little bit about why I developed Poorman, and the reason why I'm going to discuss that will become clear in a moment. And then finally I'll finish up with what the future holds, what my plans are for taking it forwards. So who am I? Well, my name is Nathan Eastwood. I'm a R developer. I've worked with R now for roughly around 11 years. Started using it in my undergraduate at Plymouth University, where I studied maths and statistics before going on to studying for a master's degree at Sheffield University in statistics. The irony, of course, is that I haven't really done a huge amount of statistics since my degrees. I mostly focus on the programming side. I now work as a freelance developer, so I have my own company, AnyData, and I've worked across various different industries. Currently I'm working in business-to-business insurance for Atradius, but I've also worked in marketing, online advertising, I've worked for government, telecommunications, energy, many more. And you can see some of the clients that I've worked with in the past. So some companies that you may recognise, such as AT&T, Office for National Statistics, NATO, Public Health England, and again, I've worked with various other clients over the years. So that's enough about me. We're here to talk about Poorman. So what is it? Well, essentially, Poorman is a feature-rich grammar of data manipulation R package. The idea behind it is it tries to unapologetically recreate the dplyr API entirely written using only base R. So therefore there are zero dependencies. There are a number of benefits to doing this. One of which is it installs in about 6 seconds, which is pretty fast. If you've ever had to install or update dplyr and its various dependencies, you can quite often be waiting quite a while. So included within the package, there are what I would say the core set of dplyr verbs, and we'll see more of what's included in a moment, but also it includes its own version of the pipe. So therefore, there is no need for the migrator package, for example. So within the package itself, as I say, there is a core set of functionality which is available. So everything from selecting and renaming columns, mutating datasets, arranging, filtering, summarizing, grouping, but also the full set of join functionality. So we can join two different tables together. And again, this can all be done using pipeability because Poorman includes its own pipe. It doesn't rely on the migrator pipe because that would of course then be a dependency, which I didn't want to include in this particular package. Now, if you've not seen dplyr before or you've not used it, I wouldn't worry about it too much. I'm going to go through a little demo in a moment. And the great thing about Poorman is, let's say you have a dplyr script. The idea behind it is that you should be able to simply swap out your library call for library Poorman, and you should still be able to run your dplyr script, which is pretty cool. So as well as the core set functionality, like say select, filter, arrange, there's also a load of other great features, which if you've used dplyr in the past, you will know these quite well. So there's a series of vector functions. These do various different bits and pieces. But also there are the window functions as well. So calculating ranks figuring out row numbers, etc., etc. But that's not the end of the story for what's included in Poorman. I actually have implemented a series of features from the wider tidyverse. So the first set is a series of functions from the tidyselect package. Now, tidyselect may not necessarily be a package name that you've heard before. It's actually a relatively new package in the sense that all of this functionality used to be included in dplyr, if I'm not mistaken. Please correct me if I'm wrong. And then they essentially removed that and placed it into its own maintainable package called tidyselect. And what these features allow you to do, if you've not seen them before, let's say that you are selecting some columns from a data set and you want to be able to select those columns based on a regular expression, or you want to take all of the columns that begin with a particular letter or end with a particular letter, etc., etc. That's where tidyselect can come in handy. And essentially, I've re-implemented and re-engineered all of that functionality and placed it within poorman. There's also a couple of features from tidyr. So at the moment, there's the replace NA function and row names to column. But again, that's not really where it ends. Poorman has a huge amount of features. Don't let the name fool you. It has a huge array of features from dplyr, but also it's starting to pull in features from the wider tidyverse. So, like I say, let's take a look at what the package is capable of. And again, if you aren't familiar with dplyr, this is a really cool opportunity to learn dplyr. dplyr is a fantastic package. It's obviously what the inspiration behind Poorman is. I just wanted a dependency-free version. So for this example, I'm going to be using the mtcars dataset, which is a dataset that comes with base R. It's in the datasets package. And essentially what this dataset is, it's a collection of cars. There's 32 of them from, I think, the 1970s, I believe. And we have 11 columns which describe features of the car. So you can see here, for example, we have the MPG, the number of cylinders, the horsepower, the weight, whether or not the car is automatic, the number of gears, etc., etc. So we use this data set just to produce some summary statistics and show some of the features of Poorman. So like I say, if you haven't seen dplyr before, there is a specific way in which you can actually read the code that makes it quite nice. And it's certainly very different, or a different way of thinking about programming to base R. So dplyr will rely on a lot of functions. For example, here, so we load the poorman package into R, then we take our dataset mtcars, and we have this symbol, percentage, arrow, percentage. This is referred to as the pipe. And the way that I tend to read this is as the word then. So I'm taking my data, mtcars, and then I'm going to select certain columns. So here I select the MPG column and all of the columns that start with the letter C. So again, starts with here is actually a feature from tidyselect, but is made available through the dplyr interface. So once I've selected those columns, I then want to mutate that data. So by mutating, I mean I want to add a new column, but it could also mean manipulating an existing column within my data. So here I'm going to create a new column called MPG2. And the expression is quite simply, I take the miles per gallon of a given car and I multiply it by 2. Then I have a second column that I'm going to create, MPG4, which is the result of MPG2 multiplied by 2 again. So of course, These expressions don't particularly make any sense in the real world context, but for the purpose of demonstration, they sort of work. Then finally, I'm going to filter the result of all of this data and all of these manipulations for the rows where the MPG, the miles per gallon, is greater than the value 28. And in the end, I end up with this resulting data frame. So you can see here there are 4 cars which meet the criteria. MPG is greater than 28. I can see I've selected my MPG column along with the 2 columns which started with the letter C, sill and carburetor. And finally, I've created 2 new columns, MPG2 and MPG4. So the idea behind this API is that it's very human readable, which is quite different to how base R works, or maybe a different data manipulation package such as data table. So it's a different way of thinking. So if we take a look at another example here, this is creating some summary statistics based on groups of the data. So here I'm going to take my data, empty cars, then I'm going to group that data by whether or not it's automatic and the number of cylinders. So once I have my data in those groups, I'm then going to summarize it, and I'm going to calculate these summary statistics. I'm going to calculate the mean of the miles per gallon, but also the sum of the miles per gallon for each particular group. So we can see here we have a resulting data set whereby for cars who are manual, with 4 cylinders, the mean miles per gallon is 22.9. Similarly, on the bottom row here, we have automatic cars with 8 gears, and the sum of the MPG for that group is 30.8. So now I've got an example of joining some data together. So this is working with 2 separate data sets. So what I do here is I'm creating a separate data frame, and I'm going to have 2 columns, the first one being the name of the car, and the second one being the price of that car. Of course, I've just made this data up for the purposes of demonstration. But we have a problem. So the empty cars data set, the names of the car are actually contained within an attribute of the data frame. That attribute is known as the row names. And in order to perform this join, I need those row names as a column of my data. And so poorman exports this function, row names to column, which actually comes from the tidyr package. But what it does is it allows me to take that attribute of the data frame, the row names, and create it as a separate column within my data set. So here I take my data set, empty cars, and I convert the row names to the column. Then I'm going to perform an inner join, which is that I'm going to take the common rows on the car column between both data sets, and I'm going to return the resulting data frame. So we can see here the result, I have the car column, and I can see that the common cars between both data sets were the Datsun 710 and the Merc 230. And finally, at the end of the data frame, I have the price data along with all of the other features of the cars. So poorman is quite smart here in that I don't have to specify the name of the column by which I'm joining on. It's smart enough to figure that out. So I'm going to do the dreaded live demonstration here and just show a few more of the features of poorman. If I can get my... Oh, I have to exit the keynote, I think. There we go. Okay. So here I have a totally fresh R session. I'm going to load in the package. And then here I have some more of the tidy select features on display. So here as an example, I can take my data, empty cars, and then I can select columns 1 through 4. And here we go. I have the resulting data set. and the columns mpg, sil, disp, and hp. And we can check those, of course, using base r, and we can confirm those are indeed the first 4 columns. But equally, we can drop columns using these tidy select features. So here I'm going to say select minus mpg. So in other words, remove the mpg column. So if you remember, the mpg column was the first column within the empty cars dataset. Then here I have, on this third row, I have, okay, take my empty cars dataset and then select everything where the column contains an S, but then select all of the other columns afterwards. So here, disp has an S, qsec has an S, versus has an S, and then finally we have all of the other columns. Another feature which is really, really nice with tidy select features is the ability to use predicates in our selection. So I can take my data, I'm going to convert my row names to a column, which is called car, and then I'm going to select all of the columns which are essentially characters. So where is .character is true. If I do that, I see the only column that is returned is the car column. And then finally, these features are also available in a function called relocate. So here I'm going to say take my data, then relocate all of the columns that end with a T, and I'm going to relocate them before the sil column. And this is my resulting data set. So you can see here drat weight before the sil column, and then I get the rest of the data frame. More recently, Poorman has had quite a lot of work done to it in terms of the features that are available for groups. So for grouping data, so here I'm going to take my data, group it by the cylinder and the automatic column, and then I'm going to split the data set based on these groups. If I do this, I get a list returned, and you can see here cylinder 4, AM0, cylinder 6, AM0, etc., etc. So I get a list entry for each of my groups. Equally, I can say, okay, well, what is the available data for a particular group or set of groups? So this is where the group data function comes in. So here I can see that for 0, so automatic is manual, and 4 cylinders, the rows 8, 9, and 21 contain those particular groups. Then finally, this was a feature requested by someone through the GitHub issue tracker. I implemented the count and tally functions, and also add count and add tally. So just quickly going through these, we can count the number of records available for each particular group. So here we can see that there are 14 cars with 8 cylinders. And finally, we can do a weighted count. So here I'm adding a new column to the end of my data set, and the number of records is in that column for the particular groups. So that's essentially what Poorman is. It is quite literally a replica, I suppose, a copy, an ode to dplyr. And probably the question at the forefront of your mind right now is, well, why? Why did I develop this? Why not just use dplyr? Well, it actually didn't start out that way. So I maintain a blog, and there was a particular blog post that I was working on, and I was working with the Magritte pipe and primitive functions within R, and ways of being able to use those primitive functions within a pipe setting. And essentially, based out of that idea, I thought, I wonder if I can use this to recreate the select function and the filter function and the mutate function from dplyr, because that was ultimately what they were doing. So when I say primitives, by the way. I mean things like, so if I was to create a temporary variable with 10 random normal values, this is what I mean. So this is actually an S3 class, and there is a method dispatch and all kinds of stuff for things like data frames and stuff like that. So that's what I mean by a primitive. So that's how it started it out, and it just became this interesting challenge to see, okay, well, can I recreate dplyr? It turned out I could. So I continued to do so. And what's quite nice about it is, as a freelance developer, as a contractor, it allows me to show off my skills quite nicely. So I have the code all hosted in GitHub with CI/CD pipelines, and these are really, really nice things that I can show to potential employers. But also, what's really nice about it is, because I maintain this blog, each time I develop a new feature, and it's particularly challenging or interesting to do within base R, it's a really, really nice way to show and teach how those things can be done in base. So those are sort of some of the more, or rather less serious reasons as to why I developed the package. But there are actually much more serious reasons as to why I developed it. So the first one is, and I've mentioned this already in the talk, within the corporate world, dependencies can actually be bad for business. So when you install dplyr, you're not just installing dplyr. You're installing a whole host of dependencies that it requires. For example, it installs glue, it installs tidyselect, and all these other packages. But of course, it doesn't end there, because those packages as well, they also have dependencies. And so maintaining that in a production environment can be very tricky. And for that reason, this is why I say that dependencies can be bad for business. Not just within the corporate world as well, but also if you're performing statistical analyses, it can also be quite difficult to maintain those and maintain those dependencies and make your analysis reproducible. Of course, there are tools out there to help, but it's not always necessarily foolproof. And so when I develop packages for my clients, I don't necessarily want to be forcing all of those dependencies and that maintenance onto my clients. But not just my clients, also anybody who uses any of my other open source packages. So I wanted to be able to use the dplyr API, but without all of those dependencies. And what's quite nice about this is one of my other open source packages, NLS timedist. So this was a package that I developed for a client a few years ago, and it was using quite an old version of dplyr, but also lazy eval, which is a package used to manage all of the non-standard evaluation within dplyr. So non-standard evaluation is essentially being able to pass arguments to a function without having to quote them, and R will, or dplyr will handle that. And of course, poorman can handle that too. Sorry, I lost my train of thought. Yeah, so I didn't want to force all of those dependencies on my clients, and NLS timedist was a package that I developed a few years ago. Literally last week, I stripped all of the dplyr and all of the lazy eval, and also another package called Broom, which is another package from the tidyverse. I stripped all of that out and I replaced it with poorman. And now the dependencies went from something like 200 and something to about 10, which is fantastic. So now whenever you need to install NLS timedist, you have a much, much nicer time of it, particularly with the installation times. So I've mentioned this earlier on, if you've ever installed dplyr or updated it, especially on a system that requires compilation, it can take so long. So that's a really nice benefit. One of the other reasons why I developed the package is that I wanted a source that was much easier to understand. So dplyr has a lot of C++ code. Now, I am not a C++ developer. And so if I want to understand what's going on, sometimes that can be quite difficult, particularly trying to find the C++ source code that matches where it's being called in R. But also, not just that, because of all of these dependencies, there can be a whole host of other packages which have C++, for example, rlang. I'm sure plenty of the other tidyverse packages have C++ in the background as well. And so finding out how these things work can at times be quite tricky. But also, one of the really bad side effects is that the tracebacks that you get when something goes wrong, the error messages, and therefore debugging those errors, it can be really convoluted and really difficult to try and piece together how this package works and how all of these dependencies work together. And so by writing poorman purely in base R, it just provides a much nicer experience for developers or anybody who is debugging the package to figure out what exactly is going on there. And finally, this last bullet point that I have here, I think this is probably the most important point on this slide. Quite often, I will see tweets or posts on Reddit, etc., belittling base R. There seems to be this common misconception that base R is just nowhere near as good or as fast or as powerful or as useful as dplyr. But what's nice about poorman is it challenges that concept directly, because poorman is ultimately written using only base, which of course is a really stable source, and therefore going forwards, hopefully that will be more stable again. Certainly within the dplyr world, oftentimes I find that functions are discontinued, they're deprecated, they're removed. Of course, you have time, but it can be quite challenging sometimes, particularly if you're developing for a client. And so by developing using only base R, you can sort of mitigate these challenges. And that ultimately led to the sort of quote that is used by the poorman package, which is, "I'd seen my father, he was a poor man, and I watched him do astonishing things." Of course, here, the father being base to the poorman package. Base is a fantastic tool. It is brilliant. I cannot recommend it enough. Of course, a large amount of dplyr is written using base. So the ability to challenge this conception that base is not good is really important to me, particularly since I've been using it for 11 years now. Now, this is probably the one question that I get asked the most about poorman, which is, how does it compare to dplyr in terms of speed? Well, I have to be perfectly honest with you, I haven't ran a single benchmark, and at this moment in time, I don't really have a great desire to. There are plenty of benchmarks comparing dplyr and base available online. I think even the dplyr package itself, if you go on GitHub, there is some benchmarks in there. I think Datatable has some comparisons as well. Ultimately, poorman is going to perform very similarly to those benchmarks because it is written using base. Now, as poorman is essentially wrappers around that, there may well be some slight overhead, but it's not going to be much. But I guess the bottom line is, and the reason why I find this question quite confusing, is that if speed is a concern, I would probably just recommend using or considering to use Datatable, which, if you look at the benchmarks, it seems to be faster than dplyr. Now, of course, dplyr does have additional backends, so you can utilize things like Spark or other various different backends. And yeah, you may get some more performance gains there, sure, but it depends on what your task is, what you need to achieve. Certainly, if you're doing a small analysis, dplyr isn't necessarily always going to be the best tool for the job. Base will do just as good a job, and then you have zero dependencies. But equally, you could consider using poorman. So, what does the future hold for poorman? So I've been developing poorman since February now. Ultimately, I plan on just chipping away at the features from dplyr, but also bringing in features from the wider tidyverse. So two in particular that I'd really like to bring in are pivot wide and pivot longer from the tidyr package. Another suggestion is I'm considering playing around with different backends. Now I know that I've said I'm not a C++ developer, and of course that's one of the negatives that I've mentioned for dplyr, or can be considered a negative. I probably wouldn't include it in the poorman package. I would maybe create a separate package just for fun, but also for my own personal learning. But what's really nice is because I've developed the package in such a way that it utilizes the S3 class system, I'm considering adding a data table backend for poorman. But this will be a completely user choice. So this will be a suggested package for poorman. If you have it installed, or if you would like to install it, then by all means, you can then potentially use poorman's API, or rather I should say, of course, dplyr's API within the poorman package, but with the speed of data table in the backend. I'm also trying out various different bits and pieces as a possible alternative to the rlang package. So rlang allows you to program with dplyr much arguably easier. There are actually ways in which I can do this in poorman already just using base. So functionality such as substitute, bquote, and all those great non-standard evaluation functions available in base. But I would like to sort of play around with those, improve on them if possible, and then eventually I will have an alternative there. Might not be the same as the way that rlang works, but it will allow you to program using poorman. And finally, everybody's favorite thing, documentation. So currently I'm working on several vignettes and a website, and hopefully they'll be live in the next week or so, but not quite there yet. So I'm not sure how I've done for time. I don't know whether I'm short, whether I'm over. I just sort of went for it. But thank you to everybody for listening. So this is where I do all the shameless plugging. So the package is available on GitHub. It is also available on CRAN if you would like to install it from there. I believe at the moment they are more or less level. There isn't much new functionality within the package on GitHub, so you can just go ahead and install from CRAN. But please, if you would like to, don't forget to star the repo. It gives me that bit of a buzz and impetus to develop more. Equally, you can tweet about it. This is my Twitter handle, #NathanEastwood_. And of course, being a freelance developer, if you need an R developer, feel free to get in touch. This is my email address. I can share all these details, of course, after the talk. But equally, I love talking about R and, of course, my package, dependencies, etc., etc. So feel free to get in touch with me about any particular topic you like, either through Twitter or through my email address. I think that's pretty much all I have to say. So thank you for listening. I don't know whether there are any questions. I saw some sort of pop up at some point, but I'm sure I'll be told if there are.
Yeah, so there was a question about speed, but you answered that one.
Oh, okay. Yeah.
Any other questions? No, I have one.
Mm-hmm.
So what was the hardest part in I don't want to say copy, but implementing stuff from dplyr?
I would say probably the context-aware side of groups. there were some certainly tricky elements there. So when you're going through the grouping side of things, so if you take your data and then group it by particular columns, you have to keep track of those groups, but also particular metadata about those groups. And I do that through a series of environments. Similarly, the tidy select features, they also work with context-aware environments. That was quite tricky to get right at first, but once I cracked it, it was okay. So I think those features took quite a while to develop, but got there in the end.
Cool. There's a question from Nathaniel about have you spoken with dplyr developers about poorman? Do they support it?
I haven't. I know that in the early days, Hadley Wickham was tweeting about it. I think he was asking the community how you would perform a grouped summary in base R, and the amount of creative ways that people came up with was incredibly impressive, using functions like aggregate and lapply, split combine, and various others, some of which I'd never even seen before, which was amazing. And somebody actually tweeted to say about poorman, but it was in very, very early development at that stage. And I can't quite remember, but he sort of dismissed it for it didn't do a particular thing that he needed it to do, which I was aware of, which was why I didn't why I didn't tweet about it myself. But no, I haven't spoken to them directly. I don't know whether they support it. I'd be interested to hear. I mean, certainly, I don't mean it in any sort of negative way. In fact, it's the opposite. You know, I'm developing their API. I'm copying their API because I think it's a good thing. It's just that I wanted a version without all the dependencies. Yeah, it'd be interesting to know.
Well, I mean, they're developing with a certain philosophy, I guess, behind having all those dependencies. There's advantages to that as well.
Yeah,
I guess. Yeah. There are no other questions. Then, yeah, no questions from me either. Thanks for presenting.
No worries.
Your slides, if you could make them available.
Yeah, sure. Will do.
Great. All right, cool. Yeah, okay. I think that's it for this